In this presentation, we are going to talk about the design of experiments. First, what are the elements of a DOE? We have factors, levels, and responses. Factors or inputs can be classified as controllable or uncontrollable variables. The controllable variables are just called factors, and the uncontrollable variables are referred to as noise factors, like people involved or speed of mixing an experiment. Levels. Every experiment has levels, and the levels are usually low, medium, and high. They're usually written in the experiment as minus for low, 0 for medium, and plus for high. The responses or outputs. The responses are usually influenced by the factors and their levels. But what does creating the design means and performing the experiment means? Creating the design means gathering data like factors, levels, responses, building the experiment, creating the analysis method, and preparing the structure and the layout of the experiment. But what does performing the experiment means? It means analyzing the data. It means conducting the analysis method selected on the data we have, like ANOVA, chi-square tests, or the response survey methods in JUMP. It also means interpreting the results and verifying the predicted results.
Hi, this is Joey Guilardi, and today I'll be talking about our design of experiments. So we have two types of data that we will be doing, and the first one is the popcorn data. As you can see up here, we have our different categories: our brand, our time, power, numbers popped, total kernels, and the second data we have is bounce data. This is for tires. We have the pattern, which basically tells for each of the decision variables whether it's high or low, negative being low, positive being high, 0 being about even or average. And we have 3 different materials: silica, sulfur, and selene. And then the last column is stretch, is what we're going to be determining using the design of experiments. So the popcorn setup, as you can see, we want to maximize the number of kernels popped and given the total kernels. So then we have the brand, the factors of the brand, the time, and the power. And we have the ranges within there. So yeah, in summary, we have our responses and our factors and basically the values for them. For brand, this is categorical data, so we have 2 different categories. This is the DOE for the bounce setup. Our response variable is our stretch, and we want to match the target of the lower limit of 350 and the upper limit of 550. And then we have the factors within here of continuous variables with ranges, as you see. So lastly, we want to see the type of underlying model used. Based on this log worth here, it seems like we're using logarithmic data or logistics equation. As far as for the popcorn data, when looking at the graph, it looked like a linear data set, and this seemed more of like the logistics pattern. And as you can see, based on our source and how it's determining this, it looks like we're using the full factorial model. Thank you for your time.
The response surface method is an optimization technique where we have several different variables and we know that they have a direct correlation to our output function or the target, what we want to achieve. The way this works is there's some kind of range where we want the output to be, usually a low and a high, and if we can get our function into there by manipulating the variables such as these x1, x2, x3, which are a quadratic equation, as you can see they're pitted against each other here and then they have them by themselves, then we know what we're going to set them at so that we can achieve our goal. Visually, this is represented by an actual surface. We can see right here it kind of makes like a concave, and that's created by setting the variables at different numbers. So say we want to measure the bounciness of our tennis balls, and there's different materials that go into making the tennis ball. We can know how much of one type of rubber we want, how much of one type of maybe a chalk or a saline that we need, and we can predict what it's going to look like, how bouncy that ball is going to be. Down here we can see once the program in JUMP has run, it has told us that at these levels we can achieve the goal that we had set before. And that's essentially what the response surface method is. We have different variables and we want to find out what they're going to be for optimally. Essentially, just a long series of linear equations where we're solving for what the best thing is going to be.
Hi, I'll be showing you how to profile and optimize using RSM. So let me open my jump 14. I'll go to DOE, Classical Response Surface Design, and here I have this table right here, and the goal is to maximize our Y response. So the values is going to just set it as -1 to 1, -1 to 1 for x1 and x2, and click Continue, Central Composite Design, and make a table out of this. And I want to Y response by randomly generating by going to Formula, Random Normal, and click OK. And here's my randomly generated numbers, and I run my R model and click Run. So here's my table. So first of all, I want to see my response surface by going to Surface Profiler, and here's my 3D graph of our RSM. And to get the optimal maximum number, I go to Optimization and Desirability and click Maximize Desirability. And here I get 0.311 for x1 and 0.394 for x2, and our Y response is about 1.695. Thank you.